Okay, so in lesson 3, we're going to talk about how what you just learned about vertex forms connects with transformations. So the first thing I want to talk about is how vertex forms and transformations are related. They are BFF. The reason we have vertex form is so we can look at transformations. So the things where we're most interested in is what's called a parent function, and that tells you how other parabolas have transformed. So the parent function for any quadratic is f of x equals x squared, or you can say y equals x squared. Those are the same things because remember f of x is the same thing as y. So this is what's called the parent function of quadratics. This is what all the quadratics are based off of. And if you graph it in Desmos, you're going to get a basic quadratic with a point 0, 0. And I didn't show you this before, but if you click on your settings tab after you've already graphed, you can look at the table of this and it'll put it into a table so we can look at the table here. You can see the vertex is 0, 0, and then it's symmetrical after that. The axis of symmetry would be right down x equals 0, and we only have one solution, which is 0 here. So this is kind of like the basic function all the parabolas are based off of. Every other parabola is shifted, stretched, compressed in different ways, and we're going to kind of talk about what that means. So the first thing I want to look at is I want to take a minute and I want to look at different functions. So let's take a look, and we're going to compare everything back to f of x equals x squared. So I'm going to take a minute and I'm just going to write our basic one here. And that's what we're going to compare everything to. So the first one I want to look at is y equals x squared plus 2. And that's a plus. So I'm going to go back to my Desmos and I'm going to plug that in. You can just write x squared plus 2. And if you look, it looks, my first point was 0, 0, and my other point is 0, 2. If I look at this point is 1, 1, and the point right above it is 1, 3. So it looks like each point has shifted up 2. Okay, so that means that this one shift up 2. All right, so let's look at something else like this. Y equals x squared minus 4. Okay, so in this one, the b value is 0, but the c value is negative 4. So let's see what happens when we just change that. So I'm going to do it again, x squared minus 4. So now I'm looking at the red line in relation to the blue line, blue curve. And so if you look, 0, 0 is where I started. And hey, look, that vertex now is 0, negative 4. So it looks like I just took that blue parabola and I literally just shifted it down 4 units. Okay, so this means I shifted down. Nothing else changed. It's just telling me where it's going along my y-axis. So if you were going to make a conclusion about this, anything added after, and I might type this to make it easier for myself, anything added on to the x squared, and I'm going to put this because it's hard for me to type that out, is going to shift the parabola up or down. Okay, so now we're going to look at shifting it a different way. So I'm going to, this is important. If you write this down, make sure to write this down. That's an important piece. So now we're going to look at different type of transformation. So the first one I want to look at is, and we're going to compare everything to f of x, our parent function, equals x squared. And we're going to say, all right, what happens when I do this? I do y equals x minus 4 squared. So if you look, now that negative 4 is inside the parentheses with the squared, and let's see what happens. If you have a prediction, that would be great if you kind of just want to think about it in your head. So if I type this into Desmos, oh look, it shifted it to the right, which is weird because this is negative. Okay, so let's try, so this shifted right 4. Oops, draw a touch, shift right 4. Great. So let's see what happens. Let's keep going. We'll do another number and see what happens. I'm going to do a positive one and just see where that gets me. So 4, if I do y equals x plus 3 squared, let's see what happens when I do this. So I'm going to go down here and I'm going to do x plus 3 squared. Oh, look, it shifts it to the left. So when it's positive, it shifts it to the left. When it's negative, it shifts it to the right, which is kind of different. So I'm going to write down shift left 3. So let's type a rule for this. I'm going to type it down here. So anything added in parentheses, I can't spell, with x shifts the parabola in the opposite direction. So, and I'll even add if positive moves right, left, and a negative moves right. Okay, so that's kind of like the rule whenever you see something that looks like that and how it transforms. So I am going to just put that as a thing that I want to remember as we move forward. All right, so let's put a couple of these together and see what happens. So I am going to hopefully move this down a little bit. All right, so let's see if I can do it here. So I'm going to draw with touch. We'll do black here. All right, so if I want to look at, I'm going to look at f of x equals x squared in comparison to x. Let me write this properly. Y equals x minus 3 squared plus 6. And remember, we're always looking at this in comparison to our function x squared. So I'm going to type that into my Desmos with just looking at x squared. So if I come down here and I do y equals x minus 3 squared plus 6. Oops. It's going to give me this parabola up here, the purple one. So let's look at how it changed. So my vertex here is 0, 0, and my vertex here is 3, 6. So how did I go from 0, 0 to 3, 6? Well, it looks like I shifted up 6 and right 3. So let's look at this. I'm going to write that down. Up, if I can write, up 6, right 3. And that kind of goes along with kind of what we just looked at. If you look up here, anything within the parentheses means I'm going to go opposite direction. So this was negative, which means I'm going to go right 3. And then on the outside of the x squared, if I add something onto the end, it's going to shift it up or down. So this would shift it up 6. Okay, so let's try another one, and I'm just going to see if I can describe it without using the graph. So the whole point of this is to look at and see if we can do it without using the graph here. Okay, so if I do this, let's see, 6, I'm going to look at the graph. Y equals x plus 2 squared minus 1. And so I'm going to, without looking at the graph, I'm going to see if I can think about what's going to happen here. So it's in the parentheses, it's plus 2. That means it's going to shift left or right, but since it's positive, it's going to go in the other direction. So this is going to be left 2 units. And then the negative 1 tells me it's going to go up or down, so it's going to go down 1. So I'm going to look at that in comparison and make sure I'm correct. So I have x minus x plus 2 squared, and then minus 1. So let's see if it does that. So 0, 0, and then I'm going to go, the vertex here is negative 2, 1, so that means I went left 2 and down 1, which is exactly what I had described here. So that means that that transformation is correct. So this is what you're kind of be expected to do, is identify what's happening to the parabola just by looking at the equation in vertex form. Okay, so I'm going to do a couple more just to show you a different transformation. So let's look at something if we had maybe a negative out front. So if I had y equals negative x minus 4 squared plus 6. So let's look at our Desmos and see what's going to happen in relation to x squared. So if I do y equals negative x minus 4 squared plus 6, let's look at what happens. So if you see, this parabola actually looks flipped. Okay, but let's look at where the vertex is. So we're going to compare point to point. So vertex here is 0, 0, as we know. The vertex here is 4, 6, which means it went right 4 and up 6. But when I added that negative, it looks like it flipped the parabola, which is exactly what happened. So if you see a negative in front of the x squared, that's going to flip the parabola. So anytime you see a negative in front of the x squared, the parabola will flip. That means if it was opening up, it'll open down, and if it opens down, it'll open up if you put a negative in front of it. So that's kind of a point to remember with the negatives. So in the practice, you're going to have to go through and you're going to have to identify what's happening to the parabola. So the first thing we're going to do is I'm going to look at an example, and we'll kind of do a couple together. So let's look at an example. I'll put in purple. Example 8. So we'll say I'm going to give you f of x equals x squared, and I will give you g of x equals x minus 4 squared plus 8. And I hope you can see that a little bit. Okay, so then I would say, what is the transformation that happened to this parabola? So your response might be for this one. Well, let's look at it. This one, the vertex for this one is 0, 0. And the vertex for this one, as you may have learned before, is negative 4, 8, or 4, 8, which means that this parabola shifted right 4 and up 8. It did not flip because there's no negative indicating it flipped, so that's my final answer, shift right 4 and up 8. So that'll be kind of what your practice entails. You might also see something like this. If I have the function f of x equals x squared, and I want to shift it to the right, well, let's do to the left, 2 and down 3, what might the equation look like? Your job might be to write what the equation looks like afterwards. So the way you would do this is you're going to take your original function, x squared, okay? And if I'm shifting to the left or right, that means I'm going to have something in parentheses. And if I'm shifting up or down, that's going to be added on to the side. So if I want to shift to the left 2, I'm going to do plus 2, because remember it's opposite. And then down 3 is going to tell me I have to do minus 3 on the outside. So this might be my transformed function with a vertex of negative 2, negative 3, and that would be shifted left 2 and down 3 from that one. So either way, you might have to do this. I'm going to go over one more example with you guys. That's a harder example. And then you should be able to be good on your practice. So number 10 we'll do. I'm going to say